we must always monitor the field samples, field strands, to understand the relationship with the vaccine samples.
Hello, I'm Peter Best. It's my pleasure to welcome you to Meet the Expert, the series of podcasts on swine health management in practice brought to you by Boehringer Ingelheim. For this episode of Meet the Expert, we continue our conversation about the porcine parvovirus, or PPV, with Professor André Felipe Streck in Brazil. Professor Streck has a PhD in veterinary sciences and is now based in southern Brazil as associate professor in the Institute of Biotechnology at the University of Caxias do Sul. Professor Streck, hello.
Hello.
Thanks for giving us your expertise on PPV. In the first part of our conversation, a previous podcast, you described how new variants of the porcine parvovirus have emerged over the past 20 years. Certainly, from a European perspective, we've detected an apparent change in predominance in the last 10 to 15 years, with a strain or strains called 27A emerging in several countries. Is 27A European, or does it occur more internationally than that?
Perfect. Firstly, I observed that the new strains are not longer equal to 27A. We can see some important amino acids substitutions or mutations in the surface, in the virus capsid, as the 27A, but also the new strains have another new amino acids. So, in my point of view, it's correct to say samples like as a 27A like sample strains. And these 27A like strains, yes, they occur in other countries, and I highlight that they occur mostly in Europe and in the American continent. Maybe in another continents, but we don't have so many information for some continents. And
Yes, I'd seen some early reports of variants emerging in Myanmar and China and so on in Asia, but they have been isolated reports by comparison with those in Europe and Americas, haven't they?
yes, mostly we can see that the most of these strains are located in Europe, and for another countries like China and another Asiatic countries, we observe another predominance of strains. We observe a greater diversity of strains in there. And also here in Europe, we observe a greater diversity of strains, or in other words, a greater genetic diversity in wild boar populations.
Mm.
But in south, in the swine industry, we observe the predominance of the 27A like strains.
Oh, right. But could you explain to me how or do these geographically distinct strains relate to each other? How alike are they? How dissimilar are they?
These strains are closely related in few amino acids in the surface. Most of these strains have important amino acids in a region called loops, and this region is very important to us because this region uh, is close in contact with the immune system of the host, and this is particularly important of these strains.
And would you say that the information we have over the last 10 years, that these new strains occurring more commonly in these countries more and more commonly, increasing extent?
Well, unfortunately, in the last mm, 5 years, we have few information. In the last 20 years, we can observe that these strains are very common in the European continent, in the American continent, and become the predominant strains in this continent. But I need to highlight that we need more information, we need more research to know what's the actual situation in the field.
I'm with you. But may I ask, I'm sure that the information is in short supply, but has this emergence of new variants coincided with an increase in submissions to diagnostic laboratories, which were suggestive of vaccination failure because porcine parvovirus positive samples were found? Do you think there's been an increase in laboratory submissions?
Yes, in my view here in Brazilian, we can observe that we have a higher incidence in positive case of porcine parvovirus, and also we observe a higher incidence of mummification here in our herds. That's quite concerning for us in Brazil. And also talking with colleagues from another countries, we can observe this phenomena in another countries as
Yeah.
well. Usually we observe EPV in like 30 or 40% of our fetus, and that's a very huge number of incidents if we remember that in some cases diagnosis came with false negative results because of the autolysis. So in my opinion, that's a very high incidence of porcine parvovirus in our
Yes,
country.
yes. So the some samples were too utilized too uh, long before reaching the laboratory, so that the testing couldn't have been uh, able to detect a virus.
Yes. The problem to perform the test of mummified fetus is that someone needs to collect this fetus, someone needs to bring this fetus immediately to a freezer to to cool this fetus, and then need to send to the lab. And sometimes this process can take some days, some several weeks to perform that. And it's quite usual to receive a fetus in the lab without the ideal condition, and that's very negative for a laboratory test.
Yeah, so I'm with you. Now, from what you say, we need to be aware then of variants when we do our monitoring. Should we be doing more sequencing to discover exactly which virus of PPV we're dealing with, not least when vaccinating appears to fail?
Yes, it's important to always perform the monitoring of new mutations. Uh, I remember that I highlight that mutations are random, and we never know when one mutation can generate escape from a vaccine. We also identify virus with different differences in according to geographic location. So it's important that all countries or all facilities can make a good surveillance of these mutations. Well, an example of this, we can now see the SARS-CoV-2 and the effect that a few years without an effective monitoring can cause for a virus. That can be very drastic for a virus.
Mm. Let me just say thank you to our listeners for joining us for this podcast where we're talking in Brazil to Professor André Felipe Streck about the porcine parvovirus or PPV. As always, thanks for joining us and we welcome your feedback. Professor Streck, let's talk about vaccinology in this case then. Could our use of established vaccines have played a role in influencing the evolution of the parvovirus by affecting the ability of variants to dominate or compete, for example?
Yes, the prediction that the main divergence between new strains, new isolates, uh, were introduced in the last 30 years. We performed this prediction, and that lead us to the hypothesis that the emergence of new capsid profiles could be due to a viral adaptation of these vaccines, and therefore it was called it. These strains were called some escape mutants or escape strains in our population. However, we performed some phylogenetic studies like population dynamics, and we could see that uh, we have a predominance of some strains, and we could see that these strains have an increase in the viral fitness as well. This indicates that the vaccine play a very important role, yes, but as well a very adapted strain that could manage to stand out from others due to a greater replicative capacity is was a important part of this process. In other words, this genetic variability usually came when the virus have more freedom to happen. And when we have a vaccine, usually we don't have all this freedom. We have uh, serious selective pressure, and in this selective pressure, we perform the predominance of some strains. This way, vaccine is important for a predominance of strains. When we have a population with a little bit more freedom, then we have a lot of genetic diversity. So the vaccine play a role, but also we have a strain with a better fitness. That's important to say. It's not all. We don't need to blame the vaccine for this for these new mutants or new strains.
In fact, vaccination would even reduce some genetic diversity, perhaps, by further effects.
Yes, we can see in some studies that with vaccination we have this predominance of strains. For this reason, it's very important to monitor these wild populations which don't have vaccines, don't have these hygienic handles that we have in the swine industry, and usually these populations have a higher genetic diversity for porcine
Oh,
parvovirus and
yeah.
also for another virus as well.
Yeah. Yes, you mentioned wild boar, and I'd like to come back to that very much because other podcasts in the Meet the Expert series have discussed the role of wild boar in relation to the spread of African swine fever. Are new variants of porcine parvovirus also being found in wild boar? And do I understand that the presence of them as non-vaccinated animals could have had an impact on the emergence of these new strains?
Yes, we can observe the higher genetic diversity in wild boars. It's important to remember the studies of Professor Daniel Cadar from Romania. With, their group perform a lot of studies in this topic, and they can see that in these wild boars they have a greater genetic diversity without a predominant of these or these strains. However, usually it's quite difficult uh, to make the transmission of the a strain from a wild boar to the pig industry, and this way I believe that habars will be important to have new genetic diversity. But what we see in the swine industry is another scenario with the predominant strains. And in my opinion, in this moment, both scenarios do not dialogue with each other.
I see. So they are separate. They have diverged, but they are within each population, but they're separate.
Should be.
Yeah, you hope. Yeah. Because I mean, controlling the wild boar population, as we've discussed in those other podcasts, is a not an easy thing to contemplate. So, thank you for that. All the evidence tells us that porcine parvovirus occurs in at least two-thirds of sow herds in just about every country where pigs are produced. We can't really think about stamping it out, therefore, we must live with it. In practice, what pieces of the jigsaw needed to protect a sow herd against PPV?
Mhm. Well, first, the vaccination must be continuous. At least here in Brazil, the swine producers only vaccinate when the farmers only vaccinate when they have cases of mummifications. And after a while, they stop the vaccination again. And obviously this cause a great circulation of the virus in our herds, and obviously cause major reproductive failures in our herds. Second, I believe that the vaccine industry, should always seek for a continuous development of the vaccine technology. I mean, strains and technology of the adjuvant and the composition of the strain, the vaccine as well. Third, we must always monitor the field samples, field strains, to understand the relationship with the vaccine samples, and also the relationship with pathogenicity. We need always to perform these studies, and with this, we'll be one step ahead of new infections. And four, I believe that new technologies for the diagnostic of parvo, like point of care diagnostic, will help a lot to do a better diagnostic.
Which are coming along, yes. Just on a practical point, if I may, repeat vaccination of all breeding animals at a site is often advised. Should we be making sure, particularly, that gilts are vaccinated twice before their first insemination?
Well, normally, in unvaccinated herds, all females should be vaccinated twice, usually at 8 to 10 weeks prior to mating, and after that for 4 weeks after that again. Um, and we make this with a booster dose, usually every 6 months. This means that the first dose of the vaccine will occur about the 6 months of age of this kid. And however, in my opinion, the problem is that maternal antibody do not last as long. Usually will last like 2 to 3 months, and this make a windows of opportunity for the virus. We can say that the virus have a 2 months, entire 2 months week of opportunity, windows of opportunity to make an infection in the cell and to establish an infection and to go to other animals, to the habitat of this animal. uh, Therefore, I believe that's important to also study this vaccination protocol, and then we can obtain then we can reduce the virus circulation in the heart as well.
Yes, because what in fact this moment does vaccination achieve? We know it can control or eliminate clinical signs, but can it go and do anything about shedding a virus and those sort of things?
No, the idea, original idea of the vaccination was only to control reproductive failure. Usually, most of the vaccines, at least in the studies, they do not prevent against virus shedding and virus infection in the cell, unfortunately. And that's also a problem because, in my opinion, the idea, the perfect situation will be the prevention of the infection, the prevention of the shedding of the virus, and also the reduction of the virus challenge in the animal habitat.
But that is an ideal situation, but
Yeah.
we're not there yet. I understand that, yes. Uh, is it possible with these new mutations of parvovirus that there could be a reduction in the neutralising capacity of antibodies generated by a commercial vaccine?
Yes, we have already been able to identify that this the antibodies generated by some old vaccine strains have their neutralization capability uh, reduced by the new strains, mainly strains as the 27A strain. And these studies were mostly generated by Professor Uwe Truyen in the 2000s, and for this reason, this was generated the hypothesis of this mutates, this escape mutants. Uh,
I was surprised that you mentioned Professor Thurn's work at Leipzig. There was a considerable reduction in antibodies in one of the studies I was reading. It was a was it tenfold reduction or hundredfold? I forget what it was, but it was an extreme difference between 27A and other viruses tested.
yes, I don't remember the numbers, but we could observe that yes, that was a great reduction, but I need to say that we could observe a greater individual variation as well in the cells and in other another animal models. we can observe a reduction in sows and in rabbits, and not only in the 27A strains, but also with mutant strains with only few amino acids substitutions, and then we can observe a reduction in this capability as well.
So just we're coming to the end of this podcast, I regret, but just to sum up, obviously you would advise all sowers to continue their vaccination schedules, to be careful on the number and which animals and so on. But you would say then your view is new vaccine developments are welcome to take account of the emergence of different dominant virus strains in pig populations and the response that they might have to the traditional vaccines.
Well, it's always I've always believed that the improvement of the vaccine technology must be constant. We have to keep in mind that this virus have a high mutation rate and will never stop to undergoing changes. And for this reason, I highlight this importance of the continuous this continuous process of the improvement. I also highlight the importance of the monitoring of these changes in countries with a large swine production systems, and also to understand that this process is geographic related, and therefore the vaccines companies should must be aware of this information, and also the customers must be aware of this information.
Yes. Professor Streck, thank you very much for your help and your advice and your expertise on the porcine parvovirus. I regret we must draw it to a close there. Thank you to our listeners, as always. It's very good of you to join us, and we will have more podcasts for you in the Meet the Expert series from Boehringer Ingelheim. But for the moment, thank you and goodbye.